Example problem number 4 for the Chapter 6 test. I have not worked this out yet on my own, so I'm kind of winging it here. Here we go. 2 ships leave the same port at, let's see here, I'm going to line up here, at 4 p.m. One travels in a certain direction at a certain speed, the other travels in a different direction at a different speed. 2 hours later, how far are they apart? That's the key. So here's the port. All right. Port. The first one travels, let's see, at a bearing, at a bearing of 38 degrees. So I drew that lining because that's north. A bearing of 38 degrees clockwise from north. We should be pretty familiar with that right now. So the first boat travels in that direction at 11.5 miles per hour. So in a sense, that's its vector. We'll go with that. All right. The second one travels at a bearing of 133. So a bearing of 133, 90 plus 43, right about there. So it's traveling down and to the right on my diagram. So there's the direction of that guy. It's traveling a little bit faster, so I'm going to make this arrow a little bit longer than the arrow I just drew. All right. So let's see here. So this green angle is 133. That would mean that this angle, I'll let change the colors. This angle right in there, 180 minus 133, 47 degrees. All right. I've got a feeling that we're going to need this angle right here. 47 plus 38 is 85. 180 minus 85. 180 minus 85. 180 minus 47 minus 38. 180 minus 85 is 95. So the angle between is 95 degrees. Alright, so here's the key though. If the boat traveling, let's see, along this path right there, is traveling at 11.5 miles an hour, 11.5 miles an hour for 2 hours. Alright, that's pretty straightforward. Double that, 23 miles. So this distance is 23. The boat traveling down to the right is going at 13 miles an hour for 2 hours. It travels a distance of 26 miles. So what we have here is, so the question's asking how far apart are they? So it's asking for that distance. The distance between the boats. So we'll call this boat A, we'll call this boat B, and then the port, we'll say that is point C. Alright, so we got a triangle there, and here is the key. We know a side of it, and the angle in between. So we have this information. We have side, angle, side. With side, angle, side, we cannot use law of sines. We cannot use law of sines because we do not have an angle and its opposite side. With side, angle, side, it is always the law of cosines. And I'm going to use that to find sides. Alright, so here's the version of the law of cosines I'm going to use. C squared equals A squared plus B squared minus 2AB times cosine of C. Make sure you are in degree mode. So this is just equal to, let's see, A is 26, doesn't matter which one it is, plus 23 squared minus 2 times 26 times 23 times cosine of 25. Alright, and that's pretty much it. A lot of people, let me go through the steps here. I recommend, I recommend doing it all in one step. And whatever is in, hold on, let me get my calculator out. Alright, we'll hide that. Just like this. Alright. What I recommend is just typing it in as it looks, the whole thing. But a lot of you guys like to break it up. So if you break it up, let's do the 26 squared first, plus 23 squared. So 26 squared plus 23 squared is 1205 minus, this is what I see a lot, 2 times 26 times 23. So that's 11 minus 6 times cosine of 95. A lot of you guys like to combine these two things. No, bad. You've got to multiply 1196 times cosine of 95. Make sure I know the right one. You know, awesome. Times cosine of 95 first. So, anyway, it's getting more complicated. It needs to be 1205 minus negative 104.2. If I'm doing this right, 1205. That's just plus 104.2. So c squared is equal to 1309.2. And then c is going to be equal to the square root of that. Second square root. 36 points. Does that make sense? Ooh, I like it. Alright. I may have done it right. Alright. 36.2 miles of flight. Alright, so there's my law of cosines example. That one's pretty straightforward. Setting up the diagram is the most important part. Alright, I'm done.